Rules for obtaining images formed by convex mirrors. In order to construct a ray diagram to find out the position, nature and size of images formed by convex mirror, we remember the paths of the following rays of light. We can call them the rules for obtaining images in convex mirrors. Rule 1. A ray of light which is parallel to the principal axis of a convex mirror appears to be coming from its focus after reflection from the mirror. Rule 2. A ray of light going towards the center of curvature of a convex mirror is reflected back along the same path. Rule 3. A ray of light going towards the focus of a convex mirror becomes parallel to principal axis after reflection. Rule 4. A ray of light which is incident at the pole of a convex mirror is reflected back making the same angle with the principal axis. Whenever or whatever be the position of object in front of a convex mirror, the image formed by a convex mirror is always behind the mirror. It is virtual, erect and smaller than the object. When the distance of the object is changed from convex mirror, then only the position and size of the image changes. There are two main positions of an object in the case of convex mirror from point of view of position and size of image. The object can be anywhere between pole and infinity and at infinity. When an object is placed anywhere between pole and infinity in front of a convex mirror, the image formed is behind the mirror, between pole and focus, virtual and erect, and diminished in size. We know that the backside of shining steel spoon which is bulging outwards is a kind of convex mirror. So if we keep our face in front of the backside of shining steel spoon, we will see a virtual and erect image of the face which is smaller in size as compared to the face. When an object is at infinity from a convex mirror, the image formed is behind the mirror at focus, virtual and erect, highly diminished. Since the image of a distant object formed by a convex mirror is highly diminished, we can see the full image of a tall building or a tree even in a small convex mirror. Please note that when the object is kept at infinity in front of a convex mirror, it is assumed to be a big arrow pointing upwards, then its image is formed at focus according to the ray diagram. If, however, the object is kept at infinity in front of a convex mirror, and if it is round in shape, then its image is formed at the focus according to ray diagram. And before we conclude the discussion, here is summary of the images formed by a convex mirror. Position of the object anywhere between pole and infinity. Position of image behind the mirror between pole and focus. Size of the image is diminished. Nature of image is virtual and erect. Position of image at infinity. Position of object at infinity. Position of image behind the mirror. Size of image highly diminished. Nature of image virtual and erect. Uses of convex mirrors. Convex mirrors are used as rear view mirrors in vehicles like cars, trucks and buses to see the traffic at the backside. A driver prefers to use a convex mirror as backside mirror because of two reasons. A convex mirror always produces an erect image of the object. An image formed in a convex mirror is highly diminished or much smaller than the object, due to which a convex mirror gives a wide field of view. For example, traffic behind. A convex mirror enables a driver to view much larger area of the traffic behind him than would be possible with a plane mirror. A plane mirror gives a narrow field of view. Due to this, if a plane mirror is used as a backside view mirror in vehicles, it will give the driver a much smaller view of the road and traffic behind. The rear view mirrors are also known as driving mirrors or side view mirrors or wing mirrors. Please note, we cannot use concave mirror as rear view mirror in motor vehicles. This is because a concave mirror produces inverted images, upside down images of distant objects. So if we use a concave mirror as a rear view mirror in a car or bus or truck, we will see the mirror that all the vehicles in the road are running upside down. Big convex mirrors are used as a shop security mirrors. By installing a big convex mirror at a strategic point in the shop owner can keep an eye on the customers to look for thieves and shoplifters among them. How to distinguish between a plane mirror, a concave mirror, and a convex mirror without touching them? We can distinguish between these mirrors just by looking into them, that is, by bringing the face close to each mirror. All of them will produce an image of our face but of different types. A plane mirror will produce an image of the same size as our face and we will look our normal self. A concave mirror will produce a magnified image and our face will look much bigger, like that of a giant. A convex mirror will produce a diminished image and our face will look much smaller. Mirror formula for convex mirrors: 1 by small v plus 1 by small u is equal to 1 by small f, where small v is image distance, small u is object distance, and small f is focal length. Since a convex mirror always forms an image behind the mirror, therefore the image distance v in the case of convex mirror is positive. The object is always on the left of mirror, so the object distance u is always taken with a negative sign. The focus of a convex mirror is behind the mirror on the right side, therefore the focal length of a convex mirror is always positive.